So is today 10.2?
10.2, yes. And I'm not going to show you how you derive, but it comes from the unit circle. And anywhere on the unit circle from the center, you have cosine and sine. And if you derive the cosine and the sine, basically you're going to get something to the effect of cosine of A minus B is equal to the cosine of A times cosine of B plus sine of A times the sine of B. My hand just froze. There you go. And from that, we can move on and do the sine and even the tangent. And you're going to see, as in the sheet, the cheat sheet, trig identity cheat sheet, you'll see that there's 3, but there's actually 6. And the reason is you can see the A plus B, and A plus B is going to be this one. A plus B is equal to cosine of A. So cosine of A plus B is equal to cosine, cosine. Sometimes you'll hear me say cosine, cosine, and that's the way I remember them. Cosine, cosine, and then minus sine, sine. Sine of A, sine of B. Okay, now you can rewrite, that's two sum and difference, or you can write it like this. Cosine of A plus or minus B is equal to cosine of A, cosine of B, and then that's going to be a minus or a plus sine of A, sine of B. And you notice that the plus coincides with the negative, and the negative coincides with the positive. Okay, so you can remember 2, or you can just remember 1. Now, they do the same thing with the sine and the tangent also. So let's do an example with the cosine. Now, here's the part that I want you to understand, and I'm going to fold this up right here because I'm going to use this in the next page. And I don't want y'all to make this hard, because there's some of you that's going to make it hard. Now, when you're using these identities, you always want to remember, back in the back of your brain, always remember what's the special angles? Well, 30 degrees, 45 degrees, and 60 degrees. Okay, you always want to remember those. And here's an example. Write 15 degrees as the sum or difference of 2 angles. Okay, so this is a test question. This is a homework question. Write 15 degrees or 15 degrees as the sum or difference of 2 angles. Well, we all know that 15 is equal to 45 minus 30, or 60 minus 45. So if that's the case, you can use 60 and 45, or you can use 45 and 30. Doesn't matter which one you pick. So I'm going to pick, and it's subtraction. And since this is subtraction, I'm going to go with my orange. So that means I'm going to rewrite this as cosine of 45 minus 30, or 60 minus 45, either one, is equal to cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And that's a negative, so this is a positive. And that's going to be cosine of AB. So that's going to be 40 and 30, 45 and 30, and 45 and 30. Now you just got to remember your special angles. The cosine of 45 is square root of 2 over 2. The cosine of 30 is square root of 3 over 2. Plus the sine of 45 is square root of 2 over 2. And the sine of 30 is 1/2. Now you just got to simplify. Square root of 6 over 2 plus square root of 2 over 2 over 4, sorry. And that's going to be equal to the square root of 6 plus 2 over 4. Now remember, this is the old way of doing it. This is by hand. All right, I'm going to show you something. Trick I learned in the war.
Quick question.
Yes.
Can it not be square root of 8 over 4?
No, you can't add. No, you can't do that. The
Okay.
only way you can add radicals, they got to be the same.
Oh, okay, I got you.
You got to have, like, if I could rewrite that now, I had 4 square root of 2 plus 1 square root of 2, that would be 5 square root of 2. It got to be the same. Okay, now what was I going to do? I was telling y'all something. Oh, let me show you a trick I learned in the war. Let's go ahead and say, what is the square root of 2 square root of 2 plus the square root of 6 is equal to, that's 3.863 divided by 4. All right, write that down, 0.9659. Now I'm going to take the cosine of 15 degrees. I better put degrees on there just in case. Ding! So why did we have to do it like this a long time ago? We didn't have a calculator. And that's how you found the cosine of 15 degrees. or you use the slide rule. All right, so make sure you write that down because that is a test question right there. That's the kind of question I would ask. Not very complicated, just straightforward. And you can check it with the calculator. Question, gripe, complaint?
No, sir.
All right. Uh-oh, COVID. All right. Now let's do cosine of 5 pi over 12. Now be careful here. And I will say you're going to use the plus. Well, let's... So think about using a plus. Now you're going to have to think about your special angles and what they represent. What do you mean, Hubert? Well, your special angles, let me go over here, 30 degrees, 45 degrees, and 60 degrees. Well, multiply by pi over 180. Multiply by pi over 180. And multiply by pi over 180. And of course you see that the degrees cancel, the zeros cancel, the degrees cancel, you can cancel some of that out. That's supposed to be 60. The zeros cancel. And then you're left with, let's see, 3 will go in there, 3 will go in there, 6. That's pi over 6. And you could say that's 2 pi over 12 or 2 pi over 12 or 3 pi over 18 or whatever. I'm trying to give you a hint there. 45, how many times will 45 go into 180? Hello? 4 times, Hubert. Thank you, class. Well, that's pi over 4. And if you wanted to give it a common denominator of 12, it would be 6 pi over 12. I'm thinking out loud. If you wanted to give it a 12, yeah, be 3 pi over 12. Yeah, 3 pi over 12. So the same thing. And then here, 6, that'd be pi over 3. Let's see, 60. Take that out. And 6 will go into 8 3 times. Pi over 3. And pi over 3, if you wanted to write it in terms of 12s, that would be 4 pi over 12. So just giving you a little bit of, you got to remember this stuff. And when you remember it, it makes things a whole lot easier. So if I wanted to rewrite 5 pi over 12, I could use 2 pi over 12 plus 3 pi over 12. So let's see what happens. cosine of 2 pi over 12 plus 3 pi over 12. All right, take a minute and plug and chug. Now we know that this is plus, so this plus right here is going to fall in line with that negative right there. All right, I want you to take a minute and do it. And if you can't do it, just consider yourself a failure. Did somebody say something? That must be somewhere else. So cosine of 2 pi is going to be cosine, cosine, sine, sine. So cosine, cosine minus sine, sine. And that's going to be 2 pi over 12. 2 pi over 12. And 3 pi over 12. And 2 pi over 12. And 3 pi over 12. And of course, you can reduce that back down. And that would be the cosine of pi over 6 times cosine of pi over 4 minus the sine of pi over 6 times the sine of pi over 4. And the cosine of pi over 6 is square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2. Minus the sine of pi over 6 is 1/2. And the sine of pi over 4 is square root of 2 over 2. And that's going to be square root of 6 over 4, sorry. Minus square root of 2 over 4. And that's going to be equal to the square root of 6 minus square root of 2 over 4. So, how do you do the sine and the tangent? You do it the same way. You put it in terms of the perfect, I meant not the perfect, of the special angles. And once you put it in the form of the special angles, then all it is plug and chug and memorization. Questions so far? Y'all awful quiet. Why y'all so quiet?
Probably because we understand it.
Do you understand it?
So far, at least, yeah.
Okay, well, that was cosine.
Doing a good job.
Yeah. What do you want? You must be wanting something. All right, here's one that's not so. Okay, but it turns out to be very simple. All right, you ready? Find the exact value. Hold on. Yeah. Find the exact value of the sum, no, the difference, no, it'd be the sum of 87 degrees and 93 degrees. Well, notice it says sum, and the only thing we know right now is cosine. So that'd be the sum of the cosine. So that'd be cosine of A plus B is equal to cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And since this is positive, that's going to be a negative. And basically, it comes down to 87 and 93 is cosine of 180. And the cosine of 180 is -1. So sometimes if they give you it written like this and you say the sum, and you only know the cosine, sum of the cosines, then you can take that 87 plus that 93 and just look and say, wait a minute, that's close to 180, and then add them together, and then you see that it does come up to 180, and the cosine of 180 degrees is -1. Unit circle. That point over here is -0. Yeah, 0 or -1, 0. Okay, now you've got A minus B, sine. Now the good thing about the sine is the signs stay the same. So I'm just going to write them down for you. Sine of, we'll just say alpha plus or minus beta is equal to, this is opposite now. The signs are the same, but it's going to be sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And the signs match, so this is going to be positive and negative. And you can put the alpha, the beta, alpha, and the beta right there. And the tangent, tan of alpha plus or minus beta is equal to, this is where tan, 1 over tan, or 1 plus tan, or tan plus 1, or over 1 plus tan. However you want to remember it is up to you, but the signs match on the top. So you draw the top here, and you go tan plus or minus tan, and that's going to be alpha and beta. All over 1, and then you reverse the signs. Minus plus tan. And that is the rest of the sum and difference formulas. So let's do one. Let's do the sine of 45 degrees. No, sine of 75 degrees. 45 would be easy. So let's do the sine of 45 degrees. So I'm going to let y'all take a second and see if you can figure out how to do the sine of 45 degrees based on what we did with the cosine. And again, if you can't do it, then we know what that means. That means pretty much that you are a failure in life. Do we have class on election day?
No, I don't think so.
I'm gonna look and see right quick while y'all are working. I hope not, because I want to stay home. I'm gonna sit back and watch the election. I have to go vote early, like at 7 o'clock. Where is the academic calendar for this class? I put it on, I put it on the handy dandy team sheet. Fall 2020 academic calendar. Fall break is November 3rd. No classes. Good. I'm going to stock up on pizza, and I'm just going to sit in that day.
Sounds like a good plan.
And pray. Oh, and while y'all are doing that, I'm making a big cheat sheet. So there we go. So we are going to use the sine of either alpha plus or minus beta. Now, 45 is, oh, that's supposed to be 75. I'm sorry. Why did I put? I told y'all 75, I hope. Okay, 75 is 30 plus what? 45. So I'm going to use sine plus, so that's going to be sine of 45 plus 30. And that's going to give me sine, cosine, cosine, sine. So sine, cosine, cosine, sine. And the plus and the minus lines up. So that means that's going to be a plus. And I'm going to put 45 here, 30 here, 45 here, 30 there. That's all there is to it. Now you got to remember your special angles. So square root of 3 over 2. I'm sorry, square root of 2 over 2. Square root of 3 over 2.
Priority 1 message coming
Plus
in on
square
secure
root of 2
channel.
over 2 times 1/2. And that's going to give me the square root of 6 over 4. Plus square root of 2 over 4. So I take my handy dandy calculator and I take square root of 2, second square root that I have to look for of 2, plus the square root of 6 equals divided by 4. And that's equal to 0.9659258.263. Or I can just take my handy dandy calculator and I can do the sine of 75 degrees. And I don't know why I got that. Oh, I didn't put degrees. Sine of 75 second angle degrees, close parentheses. There we go. And the sine of 75 degrees equals 0.9659258263. So you should feel good about yourself. Now, are most of the identities like this? Yes. I would say probably after the first 5. Okay. Remember, you've got your, let's see, you got your tangent identities. Then you've got your reciprocal or Pythagorean. Then you've got your reciprocal. Then you've got the inverse, even and odd. Even and odd, that's where they take the sign out from. And after that, after those identities, is pretty much plug and chug identities. These are the ones that are the actual property identities. And then after that, it's just like plug and chug. So I'm trying to get you to understand that so you don't look at them like, oh my God, these identities are so hard. Well, maybe some of these are, but because these are property identities, these are identities where you rewrite versus plug and chug. All right, let's do a nerd. This time I want you to do the tan of 7 pi over 12. Now, you don't have to use 7 pi over 12. If you want to change 7 pi over 12 to an angle, that would be 7 pi over 12 times 180 over pi. And the pi's cancel. 2 will go in there 6 times, 2 will go in there 90, 2 will go in there 3 times, 2 will go in there 45, 1, 15, and 15 times 7. What's 15 times 7? 105. Somebody check, help me out there. What's 7 times 15?
It's 105.
So 105 degrees. So if you feel better with 105 degrees, then do something with it. What can you do with 105 degrees? I already got it in my head. 60 plus what? Boom. 60 plus 45. Unless you like playing with those radians, playing with the pi, go knock yourself out. I already got mine. Mine's 60 plus 45. So I take my handy dandy cheat sheet, and I got 60 plus 45, so the tangent of 60 plus 45 is equal to tan, tan, 1 tan, tan. So tan, tan, 1 tan, tan. And that plus dictates plus on the top and opposite on the bottom. And now you just plug and chug. 60, 45, 60, 45. Now you can do your thing. So I'm going to rewrite this on the next page. So tan of 60 plus the tan of 45 over 1 minus the tan of 60 times the tan of 45. Excuse me. The good thing about this is you don't have to find different things because the tan of pi over 3 is the same on the top and the bottom. So the tan of pi over 3 is square root of 3. So that's going to be square root of 3 here over 1 minus the square root of 3 there. And then the tan of 45, that's easy, is 1. So you're going to put a 1 here and a 1 here. And that's going to give you 1 plus the square root of 3, or the square root of 3 plus 1, over 1 minus the square root of 3. Does anybody know what we're going to do here? Does anybody know the next step? Because it's algebra, it's not anything new. What's the next step?
You can do 1 plus root 3 over 1 plus root 3.
Now, how do you know that?
'Cause
You are just awesome. What?
What was
You're
that?
supposed to say, because you taught us that, Hubert.
Yeah, I did say
Conjugate. We're going to use the conjugate. What is in the bottom of the denominator? What is in the denominator?
that. A radical.
A radical. You don't want a radical in the denominator. So I'm going to multiply by 1 plus square root of 3 over 1 plus square root of 3. All right, finish it out. Now, everybody in here should be able to finish that out because that's nothing but algebra. The FOIL method on the top and shortcut number 2, 3 on the bottom. Y'all should be able to knock that out. If you can't, then we'll just write it up as being a failure. Square root of 3 plus 1 times 1 plus square root of 3 over 1 squared minus square root of 3 squared. Use my FOIL method first. Square root of 3. Outer, square root of 3, square root of 3, square root of 9, square root of 9 is 3. 1 times 1, I'll get that for you. And square root of 3. One minus what? 3, Hubert. And that's going to give me, what is, okay, this is your question that you were asking a while ago. What is 1 plus the square root, 1 times square root of 3 plus 1 times square root of 3?
2 root 3.
2 square root of 3 plus 4 over negative 2, and you can cancel, let's see, what would that be? That's going to cancel there, leave negative root of 3 minus 2. Somebody check me on that and see if y'all got the same thing.
Yeah, that's right.
Well, we can check it. You know how we can check it? We can type it in the calculator. You'd be surprised on how many people do identities and they have no earthly idea what they've done after they've done it. Okay? So, negative square root of 3 minus 2. And that is negative 3 equals negative 3.732050808. And now let's check it to see if we're right. Tangent. I'm trying to find the tangent button. There it is. Of, what do we say, 105? I said 105 degrees, didn't I? 105 second angle degrees, close parentheses. Bam! And I guarantee you there's somebody in this class, somebody that didn't know what you were actually doing with the sum and difference, what you were actually finding. You're actually finding the tangent of 105 degrees. And you should feel good about yourself. All right, I'm going to give you another one. What if you see one that looks like this? Sine on the test, it says sine of 40, cosine of 160. This is what they like to put on those standardized tests. Cosine of 40, sine of 160. And they just put it on there and they say solve or whatever. It just says solve. Well, you pull out your handy dandy cheat sheet, whether it's a green one or this ratchet one right here. Somebody match that one up. Well, it's sine, cosine, so it can't be cosine because it's cosine, 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 sine. So it can't be that one, so it's got to be sine. So which one is it? It's the one with minus sign, Hubert. Yeah. So that's the sine of 40 minus 160. Right? So that's the sine of 40 minus 160. And that's equal to sine of negative 120. Well, the sine of negative 120, what is 120? Well, that's 90 plus 30, isn't it? Yep, that's what it is, Hubert. Thank you, class. So that's going to be negative square root of 3 over 2. Where is negative 120? Well, there's, okay, here's negative 1, here's negative 90, because we're going in this direction, so it's negative. There's negative 90. And then 30 degrees, if you have 30 degrees, let's see, there's 30 degrees would be right here. And then 45 degrees would be right here. And then 60 would be right here. So there's your 30 right there, because this is 60. So this is your 30. So that'd be 120, negative 120 right there. So that means that your x is going to be negative, or negative adjacent, and that's going to be positive. And this is going to be negative, and that's going to be your opposite, pretty much. Students take calculus. All students take calculus. So the only thing positive is the tangent and the cotangent. So the sine is going to be negative. And now all you have to do is just say, well, what is the sine? Well, I'm using, my man is right here. So my adjacent, that's the hypotenuse, and this is the adjacent. This is the adjacent now. So that's going to be Oscar had would be H. I mean, opposite would be this one. So that's negative, let's see, 1. I'm thinking out loud, y'all. So, and this is the square root, this is negative 1. This is the square root of 3. And this is 2. So it'd be square root of 3 over 2. Negative square root of 3 over 2. Oscar had. So if you're here, the Oscar. Yeah. Negative square root of 3 over 2. What if they give you a variable? What if they give you a variable? Well, you just leave the variable there. Let's say they give you sine of 30 degrees plus theta. Or it could be sine of 30 degrees plus x. Or whatever. Well, let's take your handy-dandy cheat sheet. And you know it's going to be plus, so this is going to be plus. Sine, cosine, cosine, sine. sine, cosine, cosine, sine, plus 30 theta, 30 theta. We know our 30-degree angle is 1 square root 3 and 2. So if we know, sine of 30, as Oscar had, well, that's going to be 1/2 cosine of theta plus the cosine of 30. Oscar had a hunk. That's going to be square root of 3 over 2. Times sine. That's it. So again, when you're given a variable, you can't do anything with a variable. All you can do is plug it in and simplify. Same thing, I'll give you 2 more examples. Tangent of 45 minus theta, or the sine of 180 plus theta. There's 2 more examples right there that you should be able to do. And the only thing you'll be able to do is simplify it. So tan, 1, tan, tan, 1, tan. And that's going to be a minus and a plus, it's opposite signs. And the tangent of 45, that's going to be here. And this is going to be theta. And then here. And then there. And the tan of 45 is 1. And that's going to be 1 minus tan over 1 plus the tan. That's your answer. Y'all keeping up? Are y'all awful quiet?
We're good.
Okay, somebody tell me, have you seen these before? Talk to me.
I have seen it before, yes.
All right,
here,
I'll tell you what. Let me get y'all engaged. How many of you, raise your hands, have seen these before? I'm looking. Let me see how many. We got 19 in here today. Leave them up. Okay, 19, and we got 6. So that means, okay, let me hear from somebody that has not seen them before. You can put your hands down now. Let me hear from somebody who hadn't seen them before. Do they look like plug and chug, or tell me what you're thinking, somebody that hadn't seen them before.
This was my first time seeing it, but I'm getting it.
Good. Well, let me tell you, there's a lot of people that take trig and they see these for the first time and they're lobotomized. So consider yourself, blessed if you understand what I'm doing. All right. So let's see what else I can conjure up. Let's do that last one. Sine of 180 plus theta. And I'm going to let y'all do this one. And it should come out with, you'll either come out with a number or a trig function, one of the two. Because sometimes the numbers cancel out. So we know it's the sine. So you know you're going to use plus. So sine, cosine, cosine, sine. Sine, cosine, plus cosine, sine. If you notice how I say these things, that's how I learned them as a student. You hear me say them like, you know, tan tan over 1 tan tan. That's the way that I learned how to do them. All right, the sine of 180 is 0. Cosine of theta plus negative 1 sine of theta. And what happens to 0 cosine of theta?
Cancels out.
Cancels out. And the answer is negative sine theta. Now, congratulations, you basically have gone through the first set of identities, and it opens up all the rest of the identities, because all the rest of the identities is either a fundamental identity, which means your reciprocal or Pythagorean or your tangent identities, versus a plug and chug identity, which is like these. Okay, so that's enough for today. Y'all's brain's probably saturated. Probably feel like your brain is a sponge full of water.
Soaking up all that knowledge.
Yes. Yes, yes. Y'all are just the future of America. All right. Let me pull up the handy dandy attendance tracker, which has probably logged me out by now. No, it didn't. And 111. And Lincoln Bridges Coley. Lincoln Bridges Coley. Let me turn off the recorder, sorry.